I want to take the derivative of f of x equals x squared minus 1 quantity cubed over x squared plus 1. So for this one, we wanted to use the quotient rule. So if I have the derivative of u over v, that's the same thing as taking the derivative of u times v minus derivative of v times u over v squared. So the first thing we're going to do is take the derivative of the top, which is going to require us to use the chain rule. And so we're going to bring the exponent down, keep inside the same, subtract 1 in the exponent, and then multiply it by the derivative of the inside. And now we're going to multiply it by the bottom. So here, make sure you want to use parentheses. Minus the derivative of the bottom is just 2x times the top, which is x squared minus 1 cubed, all over the bottom squared. We're going to simplify, so the first thing we're going to do is take the derivative of x squared minus 1. So that would just be 2x. And then we're just going to leave everything else the same. Now we see what can we factor out. So we see a factor of 2x and another factor of x squared minus 1. Here the candidates are 2 or 3 as the exponent. We always choose the smaller of the two. So in this case, it's going to be 2. And then what we have left is 3 times x squared plus 1 minus the quantity x squared minus 1. Okay, so we have to be very careful with that because this negative is factored out of the x squared minus 1. So you want to keep it in parentheses. All over x squared plus 1 squared. I'm going to do some simplifying, so I'm going to do it in between step here. So 3, so distribute the x squared and 1, so that would be 3x squared plus 3. And then the negative will be distributing negative x squared plus 1. So really, 3x squared and negative x squared will be 2x squared. 3 and the 1 will just be 4. So I'm going to replace whatever's in the parentheses with just 2x squared plus 4. So I'm just going to copy down what I have. And the last step is to notice that we can factor out the 2 from 2x squared plus 4. So this 2 will come out in front, and I'm going to multiply the 2x. So that would just be 4x times x squared minus 1 squared times x squared plus 2 all over x squared plus 1 quantity squared. And that's my derivative. Okay, next problem, f of x is equal to 5e to the negative x all over x plus e to the negative 2x. First thing I'm going to do is take the derivative of the top, which I'm going to have to use a chain rule by taking the derivative of the exponent, which is negative 1, multiply the bottom, minus the derivative of the bottom, so the derivative of x is 1. The derivative of e to the negative 2x is negative 2e to the negative 2x. And here again, we want to leave it in parentheses, times the top, which is 5e to the negative x, all over the bottom squared. Next thing to notice is that they both have a factor of negative 5e to negative x. So this negative here, think of it as multiplying the 5e to negative x. So we're going to pull that out. And I'm left with x plus e to negative 2x from the first term. Okay, I'm going to put that in parentheses. And then plus, since I factor out a negative, since these both are negative, these two are negative, I factor it out, so now I'm going to add them. 1 minus 2e to the negative 2x. And that's going to be all over x plus e to negative 2x squared. Now I just want to simplify. So I have 5e to the negative x. And then there's an x here. There's a 1 here. And then we have e to negative 2x and negative 2e to negative 2x. So that would just be one copy of negative e to the negative 2x all over x plus e to the negative 2x quantity squared. And here we can't simplify any further. So we'll just leave it as it is. Okay. Next we have y equals x cubed times natural log x over x plus 2. This one is a little tricky because we have to use the product rule and the quotient rule. So when we take the derivative of the top, we're going to be taking the derivative of x cubed ln of x. Okay, so a couple things here. The derivative of u times v is u prime v minus v prime u over v squared. And if I'm multiplying the two functions, we can say, we'll call it f and g. The derivative of those would just be f prime g plus g prime f. So the first thing we're going to focus on is u prime, which is the x cubed ln of x, the derivative of those. And we're going to be using the product rule. So in this case, f is going to be the x cubed and g is going to be the natural log x. So we take the derivative of x cubed is 3x squared times ln of x plus the derivative of ln of x times x cubed. So this represents u prime. And because we have a plus sign here, you want to put it in parentheses. Otherwise, it's going to be wrong. Okay, now we're going to multiply by v, which is x plus 2, minus the derivative of v, so the derivative of x plus 2 is 1, times the top, x cubed natural log x, all over x plus 2. Okay, so now we have to simplify. I'm going to focus on 1 over x times x cubed. That's just x squared. So I'm going to rewrite that. Everything else is just going to be the same, so let's not worry about that for now. Okay, the next step is to distribute, or FOIL rather. So we're going to FOIL out this thing. So we have 3x cubed ln of x plus 6x squared ln of x plus x cubed plus 2x squared. So that's all from foiling, minus the x cubed ln of x all over x plus 2. And here I think I forgot to do the square, right? It's always the denominator squared. So let's add that in. Okay, let's see what simplifies. I have 3 copies of x cubed ln of x and 1 copy here. I'm going to be subtracting, so I'm going to be left with 2 copies of x cubed ln of x. And then just copy over the rest. Okay, next thing is identify what factors they all have in common. So they all have x, but we want to see what's the appropriate exponent. So it's really going to be 3 or 2 for this one. And like we said, we always choose a smaller exponent, so that'd be 2. We're going to factor that out, and what's going to be left is 2x ln of x plus 6 ln of x plus 2. And it's going to be all over x plus 2 quantity squared. And at this point, we can't simplify any further, so that is the derivative.